Hi everyone, welcome to the video lecture presentation on EC8393 Fundamentals of Data Structures in C. This video we are going to see the topic recursion in Unit 2. This is Satish Pandian, Assistant Professor, Department of CSC, Government College of Engineering, Bodinaikanur. So first we will see the definition of recursion. Before that, it is normally used in function. So function, in the previous video we've seen a function is a group of statements used to perform a particular task. So here a function is said to be recursive if a statement in the body of the function calls itself. So already function, we know that a set of statements, in that any one statement is a function call that calls the same function, that is recursive. So a function is said to be recursive if any one of the statement of the function calls itself. So that particular statement calls the same function, then that function is called a recursive function. Recursive is the process of defining something in terms of itself and is sometimes called a circular definition. So recursive is also called a circular definition because a function calls itself. That is given in the last point. A function can call itself. That is a recursion. So see this structure. This a function. Name of the function is do. Here we have open and close. Inside we have many statements of this function. So one of the statement is a function call which calls the same function. So function calls itself. That is a recursive or recursion. So commonly these two examples of recursive function call factorial of a number, Fibonacci series, but there are many numbers of examples available for recursive, but generally these are fundamental examples. So we will discuss this first one for this topic, factorial of a number. So I'm going to find a factorial for a number. So I want to declare a function first before the main program. So return type. So here I am using the return type as integer. Previous programs we used void. Void means no return value. Here I am using integer. So function should return one integer value. Now name of the function is fact because we are going to find a factorial. So name of the function fact. So for factorial we have to give one input. So one integer argument I am creating. Okay. So for this integer value we are going to find a factorial. Now below the main program we will define the function. So return type is integer, function name is fact. It uses one argument that I am using x. Okay. For x we are going to find factorial now. Okay. If the value of x is 1, what is factorial value of 1? It is 1. So here I am returning the value 1. If this value of x is 1 means the factor value is 1, that we have to return. Otherwise factorial, you know, suppose a factorial of 5 means 1 into 2 into 3 into 4 into 5. Similarly factorial of 3 means 1 into 2 into 3. So like that we have to calculate. Suppose here x value is 5 means we have to multiply 5, 4, 3, 2, 1. That is 5 factorial. So here we have to return x star. So x value 5 means 5 star 4. So for 4 again I have to call the same function. So fact of x minus 1 I am giving. Okay. So initially x is 5 means this x minus 1 will come 4. Okay. So that's all. So now we can close the function. Okay. So this is a factorial function. We will execute this. Here come to main program. I want to get input. So for input one variable I am creating. For storing output another variable I am creating, a comma b. A is for getting input, b is for storing output. So in this scanf first get the value %d ampersand address of a. In a I am getting input. Now we have to call the function. Name of the function is fact. So use the same name, fact. You have to give value of a. Okay. So what is the value of a? Suppose if you give the input as 5, 5 will be passed. That 5 will be stored in x. Okay. So here you have to check whether x is equal to 1. it's not x is 5, so it will come to else part. So return x star fact of x minus 1. So x value is 5, so 5 star fact of x minus 1. So again we are calling the same function. So x minus 1 means now the value 4 will be passed here. Okay. So previously 5, so 5 star fact of 4. So again we are calling the same function inside the function. So this is called a recursive function call. So now x minus 1 means while calling again the x value now becomes 4. So this if condition is false, it will come to else part. So return x star. Now x value is 4. Previously it was 5 star, now 4 star. 4 star fact of x minus 1. Now 4 minus 1 3. So now 3 will be assigned to this x. Again this if is false, it will come to else. Return x star. Now 3 star. Already 5 star, 4 star, now 3 star. So 3 star fact of 3 minus 1. 3 minus 1 means 2. So 2 means again this if is false, come to else part. So here 2 star fact of 2 minus 1. So previously 5 into 4 into 3 into now 2 also came. So again recursive function called 2 minus 1. 2 minus 1 is 1. So if now whenever x is 1, this condition is true, so return 1. Now that 1 will be substituted here. So our recursive function call stops at this place. So we have 5 into 4 into 3 into 2 into 1. So everything will be multiplied. The value is 120, that will be returned because we are using return statement, that will be returned to main program. Here we are using return so that the return type we used integer. If we use void, we cannot use this return statement. If we use integer, then only we can return. So this return value will go to the function call, this statement. So here we have to get that return value. So in the left hand side we have to read. So I am using b equal to, b is another variable created here. So b equal to fact of a. So whatever value we are returning, that output value now stored in b. Here using printf we can display the value. So printf just to display that value, percentage d, output is in b. Okay, that is factorial value. Just we will compile and execute this program. So compile it, no error, execute. Suppose I want to find 5 factorial, so give the input as 5. So here percentage d. Okay. So give the input as 5. So output we are getting is 120. So 120 is the 5 factorial value. Okay. So this is how to use a recursion. Okay. So this is called a recursive function call. So inside the function fact, we are calling the same function using the function call. This is a recursion. Okay. So the main advantage of recursion is decomposition into smaller problems of same type. Okay, if you have large problems of same type, we can easily decompose into small parts. Recursive calls must diminish the problem size. So problem size is reduced because I want to execute a function 10 times. You can repeatedly call. So the size of the problem is reduced. Necessity of base case. So base case means anything we can keep it as common. That is called base case. So any number of times we can use with the help of recursive call. So that is a base case. A base case must be reached. So for recursive function call, what we are creating as a base case, that should be easily accessible. That is base case must be reached. So these are advantages of recursion. So that's all about recursion. Thank you.